As the number of joins increases, overall query cost will go up exponentially. Controlling that complexity is a major component of both query tuning and ongoing improvement in the PostgreSQL optimizer. Every use of a sequential scan or index lookup will be magnified as those results are then joined to additional tables. During the planning process, PostgreSQL tries to check all possible join orders. In many cases, this can be pretty expensive because there could be many permutations, which naturally slows down the planning process. Consider the following example. Create table 1 as select all from generate series from 1 to 5. We'll create 2 additional tables like this. And now we will see how we can join these tables. Select all from table 1, table 2, table 3, where table 1 ID is equal with table 2 ID and table 2 ID is equal to table 3 ID. Or we can do select all from table 1, cross join table 2, cross join table 3, where table 1 ID is equal with table 2 ID and table 2 ID is equal with table 3 ID. Or we can do the following query, select all from table 1 joining with table 2 which joins with table 3. Basically, these three queries are identical and treated by the planner in the same way. However, the first query consists of an implicit joins and the last one consists of only explicit joins. PostgreSQL will do searches for an optimal plan, but this is time consuming and has the potential to make bad decisions. If you know the right way to join the table efficiently and want to reduce the planning time, you can force the order of execution. You can tell the optimizer to use the order you specified when doing a series of explicit join operation, as we did in the last example. Also, you will need to reduce the parameter join collapse limit from its default value of 8. By lowering this parameter to 1, you will prevent all join reordering. The default value is reasonably good for normal queries. However, if your query contains a very high number of joins, playing around with this setting can reduce the planning time considerably. Reducing planning time can be essential to maintaining good throughput. Alternative plans won't be considered. This can be very useful in two main contexts. First, if the query planning time is large for a particular complicated join, discovering the usual order of execution and making it explicit in the query can save significant planning time. Second, in cases where the order selected by the optimizer was poor, you can use this ordering as a hint. To see how the join collapse limit variable changes the plan, you can test it via a simple query. But first, let's create some test data. Create table A as select all from generate series from 1 to 1000 as ID. We'll do 3 more tables. Now let's execute a simple join query. Explain with X as select all from generate series. And we'll select from this as A, then join with B, then join with C, then join with D. It has the following query plan. Now we will set the join collapse limit to 1 and see how the plan changes. In order to get the best performance when running a query with many join operations, let the planner choose the best order of operations at first, then you can set the order explicitly and this will help you reduce planning time. If you found this video helpful, you could check the whole course on Udemy using the link in the description. By using that link, you'll get a 60% discount. I hope you'll get on board to find more tips like this to optimize your PostgreSQL like a pro.